Hi guys, so welcome back. In the previous video we had a look at simple math notation. We had a quick run through, very high level, on some simple differentiation. I did link in the previous video to one of the videos where they go through a bit more detail around calculus and specifically around single variable differentiation. Have a look at that if you want more in depth. But today what we're going to have a look at, we'll go through straightforward linear regression, quite simple linear regression I should add, and we'll look at how you solve it, and some of the how some of the differentiation and calculus behind that as well. So let's get cracking. So okay, let's start off, having a look. Let's make this kind of statement. So we've got our data set here, and that's made up of two variables. We've got x and our y, right? And in this sense, if you think about it, right, so these are our inputs, right? And these guys, this is our target, right? And that's how it is. Now, for the purpose of this, we're going to make straightforward, for this section, we're going to make this assumption that x is, one-dimensional, right? And so is y, right? So these are both one-dimensional vectors. And what that means is we can quite easily just draw this scatter graph out, right? So we have our x and we have y here. We can kind of draw, some points like this. And we've got our x and y scatter plot. Now, what we're going to try and do with linear regression really is to fit this unknown function. So we're going to make this assumption because, well, we can do, because again, like we said, it's one-dimensional, that we're going to have this linear line. So we've all seen this, the simple linear graph. That's what we're going to try and fit to. So how are we going to go about doing that? Well, first of all, we can start off by making some estimates, guesses to what this m and this c could be, right? And by doing that, we get to a point where, for all of our various guesses of m and c, we can say, well, we've got some error function here, error value, and what that allows us to do is, well, if we look at this standardized error, well, great. So we can get to that standardized error by this function, for all values of I and I, where we have yi minus our functional form that we've come to estimate. We're going to square that. The reason we're going to square that really is so we just have we have a positive value, and we're not going to get into kind of weird oddities. And this is essentially our square mean error, right? And that mean error is going to give us a sense of, well, how far off, are we with our guesstimation of this functional form. Okay, so that's great. We've got somewhere to head to. Okay, so how do we go about this? Now, just to make it so it relates back to your course notes, for example, I'm going to change this function we've got here, and just change it marginally so that we have an a and we have a b instead, right? So we have a y equals ax plus b, and those, you can see that relation. So this is the function we're going to work off, right? And this is then in this sense here, that's our f of x, right? Okay, so there we go, right? We've got this error function. Now, what do we want to do? Well, we want to be able to find the values of m and c that is going to minimize this error, right? And to do that, we're going to substitute the function in. So we're going to have our error is equal to, right, this functional form. I yi minus ax minus b squared. Well, okay, let's go ahead and expand this guy out. What do we have here? I'm gonna have this, right? So I'm gonna skip over a couple of bits, and I'm just gonna change the notation at the bottom just to make just say it for all I. Well, we're gonna have this is gonna be squared, so yi squared. That's gonna turn into a plus, right? And then plus b squared, and then each one of these terms is going to multiply by the rest of it. So plus yi minus axi minus b. Oops, I'm getting carried away here. Minus b, and then minus axi times yi minus b, and then last but not least b axi. So that should be minus. And oops, sorry, I should probably write this right around. Y minus axi. Okay, brilliant. So that we've got this function. This is a very long equation. Let's simplify that out just so that it doesn't look so bad for us. Y squared I plus a squared x squared I plus b squared. Well, let's multiply that inside out. We're going to have minus, so we'll put the a out in front here for us. Xi yi minus b yi minus again a xi yi plus a xi, which will probably pop the b in the front here, and then we're going to have minus b yi plus b a x I, right? So we've got this really long thing. Well, okay, we can simplify this further for us. See some terms that look very similar to each other, except for these guys here, which will remain squared x squared plus b squared. Okay, we've got two of these. So there's 1, 2. Well, that becomes a minus 2 a xi yi. Got another 2 of these, right? So we can go minus b yi. And then last but not least, we've actually got 2 of these guys. So that's brilliant. So plus 2b a xi. Now in your course notes, the way that these are laid out slightly different, but I hope you guys can see how that all works. Now, to make our notation even simpler, if you remember from the previous section, I mentioned that we can have this, the average, right? So for all I of xi, so this is actually, we can replace that and just say it's equal to x bar. Well, we've got a couple of instances of that. Slight variance. So y squared, for example, if we consider that to be our xi, well, okay, great. Now we have this y squared bar plus, well, we've got an a squared x squared bar plus a b squared, and then we're going to have this 2a xy bar. We're going to have this 2b y bar. And last but not least, we're going to have this 2b a x bar, right? Now we've got a nice simplified equation that we can work with. We've got a couple of variables. We've got our a, our e, our a, and our b. Well, what's that look like? If we think about it, well, we can draw this slightly out. So we can actually think, well, this is a three-dimensional plane, right? What I mean by that is you can draw this in a three-dimensional way. Again, you'll notice in your course notes it's much better laid out, but basically we have this plane that we want to work with, right? And we're looking for the point in this plane where E is at the minimum, and then we're going to try and find our A and our B. Well, how do we do that? If we recall back to our conversation around differentiation, we had a way of looking at in the kind of single variable mechanism for finding where we have a minima. It's the same. It's exactly the same. Even when you have multivariable. The only difference is rather than doing a full differential, we're going to do what's called a partial differential or a partial derivative. And that's really, the notation for that is like a partial d, right? So we're going to have this partial d by this partial a. And what that's saying is, well, we want to know how a single change in a is going to impact our e. And same here, we're going to do this for b's. We're going to have this partial, partial e by partial b. We're going to look for how a single change in our b is going to impact our a. So we got these two notations, quite nice and simple, and that can kind of expand this out. So we can start to look at this, right? So here, for example, we have our a to the power 0 and our b to the power 0, right? On this one, we have a b to the power 0. We have an a to the power 0 here. We have a b to the power 0 here. We have an a to the power 0, right? So we've got them there, just the power 0, just to make our simple. So when we're differentiating this with respect to a, let's look for instances. Well, we have an a0. Well, that's going to bring a 0 down, so that's going to disappear. We have an a to the power 2, so we're going to bring that 2 down. Now I'm going to put the x bar in front, the x squared bar in front, because that's a constant term. And then we're going to have this a. Right? Now the b to the power 0 is just 1, so I'm going to ignore that. Here we have an a to the power 0. Well, okay, great. That's going to disappear for us. Well, we have an a to the power 1 here, which we do need, right? Let's get rid of this. So it's going to be a minus 2, and then the a to the power 0. 1 minus 1 is 0, leaving us with an xy bar, right? And then here we look at this. That's not going to give us anything. This is the last one. So that's going to give us a 2bx bar. Right? Okay, great. So we have our partial derivative for a. Now let's look at the partial derivative with respect to b. Same thing, we'd go through. We're going to look for all instances where we actually have a b. We've got a 2b here, right? So that one. We've got no b there. We do have a b here, so we're going to have a minus 2. Well, the b disappears, leaving us with a 2y. Great. And then last but not least, we have a b here, which leaves us with a plus 2ax bar. So how do we now look for the minima? Well, that's quite simple. We're going to set each one of these derivatives to equal 0, and then that will give us where we've got the minimal point, right? So let's pull down here. We're going to set these to 0. Well, okay. Let's set the first one to 0, and that will then lead us to actually find an equation which has a and b in it, and this one as well. Now I'm going to skip over some of the math here, and I'm kind of going to give you guys the final answer for your a and b. Now, if you want to continue working on the math, or if you'd like me to expand on it, please do let me know in the comments or with a direct IM. But basically, what we're going to have is we're going to have an a, and our a is going to look like our a is going to look like. So our a is going to look like x bar, y bar, minus x bar, y bar, over x squared bar minus x bar squared. Now do make sure that you can see the difference between these. And then our b is, well, quite simply, our b is going to be y bar minus 2ax bar. So there you go. That is then the way to solve, to find your minimum values, and we get our a and our b. Okay. I hope you found that useful. If you've got any comments, if you've got anything you'd like more expansion on, please do let me know in the comments or directly message me. In our next video, we'll look a bit more into matrix algebra, matrix manipulation, calculus kind of thing, to expand on this and actually get into where you have a multi-dimensional X rather than our single dimensional. We get into that matrix side. All right, guys, catch you later. See you at the next slide event. Bye now.